Hello everyone, this is Raju, Assistant Professor of Chemistry, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today our topic is surface coating. In the surface coating, the mainly we discuss about the electroplating, electrolysis plating and metal cladding. So these all topics today class we discuss. So before we are discussing about the electroplating or surface coating, in previous class we discussed about the surface coating, that is a hard dipping process. In the hard dipping process, so the base metal is immersed in the molten coat metals. So that is called as hard dipping. So these hard dippings are mainly two types of hard dippings are there. So that is the galvanizing process and tinning process. In the galvanizing process, the base metal is that is iron metal, we are immersed in the molten coat metal zinc. That is called as galvanizing. And tinning means the base metal iron, we are immersed in the molten coat metal tin. So that is called as a tinning process. So in the galvanizing and tinning process, maximum the base metal, first of all, we are immersed in the acid. That means acid pickling takes place, then water bath, then drying takes place, then we are passes through flux, then molten coat metals. Lastly, we are passes through rollers. Excess amount of zinc or tin is present. We are extract from the rollers. Then we are getting the galvanized and tinning sheets. So this one we are discussed in the previous class. Now we are discussing about the electroplating. Electroplating means in presence of direct current, in presence of current, where that article or that substance to be plated. That means on the surface of the metal, on the surface of the base metal, we are coated. That is in the electroplating process, the deposition of metal ions on the base metal by applying the direct current, in which the electrolyte solution containing which metal ions are deposited on the base metal, that metal ions must be present in the electrolyte solution. That means, suppose you see, it's a container. In the container, so this is the cup. So this cup, I want to give the copper coating. I want to give the Cu coating. The deposition of which ions? Copper ions. The deposition of Cu plus 2 ions on the base metal by applying the direct current. And the electrolyte solution, this substance is that article is in the cup is in cup is immersed in the electrolyte solution. That cup is immersed in the electrolyte solution. This electrolyte solution must be contains which metal ions are deposited. That means we are giving the copper coating, then the electrolyte containing copper sulfate solution. The electrolyte solution containing copper sulfate solution. This is called as electroplating. Electroplating means the deposition of metal ions on the base metal by applying the currents, in which the electrolyte solution contains the which metal ions are deposited on the base metal, that metal ions are present in the electrolyte solution. This is called as electroplating process. In the electroplating process, the base metal, any on the surface of the base metal, any oily or greasy substance are present, that will be removed by using the solvent like benzene, toluene, tetraethyl acetate, etc. These are organic solvents we are using, then we are cleaned. Then after that, acid pickling takes place. That means dilute HCl or dilute HCSO4, that plates we are dipping. Then we are giving the electroplating. How we are giving the electroplating? Let us see. Electroplating is the process of coating metal and non-metals to change their surface properties, such as to improve the appearance and corrosion or chemical attack. The electroplating is the process. When electroplating process takes place, when electroplating, copper electroplating takes place, that appears, that improves the appearance, that improves the appearance of the base metals and protect you from corrosion. Electroplating is the electro deposition of metals by means electrolysis over surface of metals, alloys or non-metals. So you see, this is the electroplating diagram. So in the electroplating diagram, so this is the key. I want to give the key to the copper coating. So this is the key. This key is immersed in the electrolyte solution, and this is the wire we are connected to the electric current, and this one connected to the anode. Anode is the copper or graphite. Graphite rod or Cu rod. Here I want to give the copper coating. I want to give the copper coating means what? This electrolyte must be contain copper sulfate. That must be contains copper sulfate. Now when we are giving the current, when electrons are flows from anode to cathode, the electrons are flows from anode to cathode through an external source. Here the electrolyte solution contains the copper plus 2 ions. This copper plus 2 ions are migrated towards to the key. Then the copper plus 2 ions are deposited on the key. Then the key is copper electroplated. Copper electroplated. Electroplating means what? The deposition of metal ion, that means copper ions on the key by applying the current. In which the electrolyte solution contains which metal ions are deposited. Which metal ions are deposited? Copper plus 2 ions are deposited. That metal ions are must be present in the electrolyte solution. That is copper sulfate solution. So in the electroplating process, you see, this is the bowl. So in this diagram, so this is the bowl. So that bowl or article to be electroplated of copper electroplating. Copper electroplating means what? That electrolyte must be contains a copper ion. That means Cu plus 2. That means the electrolyte is the CuSO4 solution. CuSO4 solution. And anode is the copper coated metal. Copper coated metal. Impure copper coated metal or graphite or platinum in anode. Now to the article, that means this is a bowl. To the bowl we are connecting a wire, that wire connected to the DC, and the DC connected to the copper coating metal or graphite or platinum. When we are applying the direct current DC, anode, this is the, what is the nature of anode? Losing of electron takes place. From anode, the losing of electron takes place. The electrons are flows from anode to cathode. When electrons are flows from anode to cathode, the electrolyte solution contains the Cu plus 2 ions. So this Cu plus 2 ions are migrated towards to the bowl. So this Cu plus 2, when direct current is applied, the Cu plus 2 ions are deposited on the bowl. Now that bowl is copper electroplated. So this process is called as electroplating process. In the electroplating process, the metal ions, the deposition of metal ions, that means the Cu plus 2 ions are deposited on the metal ions by applying the direct current, in which the electrolyte solution must be contains which metal ions are deposited on the bowl or key. That metal ions are present in the electrolyte solution. This process is called as electroplating process. Electroplating of copper over metal objects. So this metal object is to be plated, is first treated with diluted Cl or H2SO4. The cleaned object is made cathode. So whatever the object is there, object or article is there in a bowl or key or coin, so that must be acts as a cathode of an electrolyte cell, and pure copper plate is there, that copper plate is the anode. So this copper sulfate and dilute H2SO4 solutions are taken as electrolyte solution. When the current is passed from the battery through the solution, copper dissolves in the electrolyte solution and deposits uniformly on the metal object. So let us see, when we are applying the direct current through the battery, the solution contains the copper, dissolution takes place. That means Cu form as a Cu plus 2 plus 2 electrons. When we are applying the direct current, then the metal ion, that means Cu plus 2 ions are migrate towards to the cathodic side. That means on the key or on the ball, on the coin or on the article, the Cu plus 2 ions are migrated or uniformly deposited. In this electroplating of copper, the chemical reactions are copper is form as a Cu plus 2 electrons at anode. At cathode, Cu plus 2 2 electrons form as a Cu. So this Cu is uniformly deposited on the key or ball. Key or ball. So that reactions later we are seeing. At anode, Cu form as a Cu plus 2 electrons. At cathode, Cu plus 2 electrons form as a copper that deposited on the base metal. Let us see the diagram. So you see, so on the ball, the Cu plus 2 ions are deposited. So this is the copper rod. This is the DC. Now migrated on the ball. So that ball is completely copper electroplated. So in the copper electroplating of copper, the conditions are anode coating metal is a pure copper plates, and cathode is the metal objective, either key, coin or bowl. Electrolyte is the copper sulfate and dilute H2SO4, and temperature is 40 to 45 degrees centigrade temperature, and current is 30 to 40 milliamps per centimeter square. These all are the conditions for electroplating of copper. The anode is the pure copper and the cathode is the metal objective, that is key or bowl or cup. Electrolyte is the copper sulfate and H2SO4, and temperature is 40 to 50 degrees centigrade, 45 degrees centigrade temperature, and current is the 30 to 40 milliamps per centimeter square. Applications of electroplating are: this process is widely used in automobiles, aircraft, etc., and plating for decoration. So when electroplating process takes place, that means on the surface of the bowl, when we are copper plated, that is decorative. That means looks like shiny or decorative. Appearance is good. This process is also used in refrigerators, jewelries, radios, cams, for typewriters and umbrellas, watches, etc. So which one? This electroplating process mainly we are used for wrist watches. We are giving the silver coating, gold coating, or platinum coating, and on the cameras also we are giving the coating, silver or gold, copper coating. For jewelries, that means ornaments. On the ornaments we are giving the rolled gold ornaments are there. On the metals we are giving the gold coating or silver coating or copper coating. On the refrigerators also same. On the refrigerators any articles are there, to that we are giving the copper coating or nickel coating. The plating on non-metallic materials. So these all are the electroplating articles to be electroplated. You see. So this is a wristwatch, and this is the jug, and this is a jug here. This is the copper coated, and this is a silver coated, and silver coated. This is the tap. On the tap we are giving the silver coating or nickel coating, etc. So this is the coating of electroplating. Now next one is the electroless plating. In the electroless plating, mainly we discuss about the electroless nickel plating. In previous we discussed about the electroplating of copper. Now we are discuss about the electroless plating. Electroless plating means the absence of current, absence of direct current. Then we are less nickel plating takes place. How the electroless nickel plating takes place in the absence of current, let us discuss. In previously we have discussed about the electroplating in the presence of direct current, but here absence of direct current we are plated, that means nickel plating takes place. Electroplating is a technique of depositing a noble metals from its salt solution on a catalytically active surface of the metal to be protected by using a suitable reducing agent without using electrical energy. In the electroless plating, we are using the suitable reducing agent. Reducing agent means what? The substance which gives electrons. The substance which gives electrons to other substance. So that is called as reducing agent. Reducing agent, the substance which gives electrons to other substance, that is called as reducing agent. So is the losing of electron takes place, the reducing agent losing of electron takes place, then that is oxidized. In the presence of without using any electrical energy, we are using this process. That process is called as electrolysis plating. The reducing agent reduces the metallic ions to metals, which gets plated was that catalytically activated surface, giving a uniform thin coating. When reducing agent means what? Losing of electron takes, which gives electrons to other substance. The reducing agent gives the electrons to the substance, that means article or substance, or which substance is electrolysis plated, to that they are giving the electrons. That is oxidized. Then the electrons are deposited on the surface of the base metal. So in the electrolysis plating, the main equation is metal ions plus reducing agent form as a metal deposited plus oxidizing products. So in the electrolysis plating, the metal ions is reaction with the reducing agent. That means the reducing agent is gives electrons to metal ions, then form as a metal. The metal deposited plus oxidizing products. So electrolysis nickel plating having 3 steps. In that, first step is the pre-treatment and activation of the surface. So in the electrolysis nickel plating, 3 steps, we are observed 3 steps. In that, first one is the pre-treatment and activation of the surface. So the surface to be plated is first regreased by using organic solvent or alkali, followed by acid treatment. That means the base metal is pickled. That means we are immersed in the acid or alkali. Example, the surface of the stainless steel is activated by dipping in hot solution of 50% dilute sulfuric acid. The surface of stainless steel, suppose we are using the stainless steel. To the stainless steel, I want to give the nickel coating. So that one we are dipping in the 50% of dilute H2SO4. The metals and alloys like aluminium, copper, iron, brass, etc. can be directly nickel plated without activation. The metals and alloys like aluminium, copper, iron, brass, etc. can be directly nickel plated without activation. Non-metallic articles like plastics, glasses are activated by dipping them in the solution containing SnCl2 plus HCl, followed by adding PdCl2 solution, that palladium chloride solution. On drying, a thin layer of fluid is formed on the surface. Non-metallic articles like plastics and glasses, where activated takes place. In that, we are using the SnCl2 plus HCl, and this one we are dipping in the PdCl2 solution. On drying, a thin layer formation takes place. Metals and non-metals like that. So that is a step 1. Now, next step 2. So in the step 2, plate bathing. That means the plate is bathing takes place. Plate bath consists of the following ingredients. So that is coating solution. That means we are giving the electrolysis nickel coating. So coating solution is nickel chloride NaCl2, and reducing agent is sodium hypophosphite, and complexing agent is sodium succinate, and buffer is a sodium acetate. In the plating bath, coating solution is which coating we are giving? Electrolysis coating nickel. So coating solution is nickel chloride. Reducing agent is sodium hypophosphite. Complexing agent is sodium succinate. Buffer is sodium acetate. So that optimum pH value is 4.5. The sodium acetate buffer solution pH value is 4.5, and optimum temperature is we are used 93 degrees centigrade. In the step 2, coating solution, reducing agent, complexing agent, buffer, optimum pH value, and optimum temperature we are used. So that is a plate bath. Now, next step 3, procedure. How the electrolysis nickel plating takes place, and what is the reducing agent losing electron takes place. How the nickel Ni plus 2 ions are deposited in the metal ions on the metal base metal. Let us discuss. So this pretreated object is immersed in the plating bath for the required time. So that plate is an iron, steel is an iron plate, or this one, we are immersed in the plating bath for required time, during which the following reducing Another nickel gets coated over the object. The reducing agent and nickel, then in that, nickel is coated on the object. At anode, the sodium hypophosphite NaH2PO2 is the reaction with H2O that form as a sodium hypophosphate formation takes place, and losing of electron takes place at anode. So this is called as the reducing agent. Sodium hypophosphate is the reducing agent. Losing of electron takes place, that gives the 2 electrons. At cathode, the nickel plus 2, that is in the form of NiCl2, nickel plus 2 gaining of 2 electron takes place, that form as a nickel deposited on the base metal. So applications of electrolysis plating. Electrolysis nickel plating is extensively used in electronic appliances. So this electrolysis nickel plating is mainly we are used in circuits, electronic appliances, circuits, cams, and mobiles, and TVs, cams, laptops, etc. In that purpose, they are using the electrolysis plating process. Electrolysis nickel plating is used domestic as well as automatic fields. So this electrolysis plating, nickel plating is mainly we are used in domestic and automatic fields. This application is used making jewelries. That means electrolysis plating also used in making of jewelries. Electrolysis nickel coated polymers are used in decorative and functional works. So electrolysis nickel coated as in, so this polymers mainly we are used for decorative and functional works purpose. We are using the electrolysis nickel plating we are applied. So electrolysis copper and nickel coated plastic cabinets are used in digital as well as electronic instrument. The electrolysis copper and nickel mainly we are used in electronic instrument. Like you see, this is a circuit board. In the circuit board, we are giving the nickel coating or copper coating. So these all are the applications about the electrolysis plating. So in the electrolysis plating, the articles are you see. So this is the image. How the electrolysis plating of nickel takes place, you see. So that is the ball, that is the article. The article to be electrolysis plated by nickel coating, and this one. So these all are about the electrolysis plating process. So next topic is that is metal cladding. So metal cladding means the base metal is coated with a dense, that is called as metal cladding. In the metal cladding process, the base metal is sandwiched between the other metals. Then the metals we are processed through the rollers. When we are applying the temperature, pressure, then we are getting the sheet. To the sheet, on the corners of the sheet, we are giving the welding, or we are using the rivets or screws, then fitted. So that are mainly the metal cladding process, mainly we are used in aircraft industries. How the metal cladding sheets are formed, let us discuss now. So the surface to be protected is sandwiched between two thin layers of coat metal and pressed between rollers. So that base metal is pressed between the rollers. The finished product may be welded at the edges or riveted at the some points. At the some points, the base metal, we are getting the base, after getting the process, we are getting the sheet. The sheet we are edges welded, or we are any other any areas we are riveted with screws. The coat metal has to be anodic to the base metal, and only plain surface can be cladded. This method is used for coating of aluminium, chromium, nickel, duraluminum, etc. So this is the diagram of cladding of duraluminum. So see in this diagram, so this is the duraluminum. This is the duraluminum. This is the aluminum. Aluminum is 95.5% of aluminum we are taken. So duraluminum is sandwiched between the aluminum, that is 95.5%. So these both are the rollers. Both are the rollers. So duraluminum is sandwiched between the aluminum. We are processed through the rollers. We are pressing through the rollers by applying the temperature and pressure. Then we are getting the egg clad sheet. So this simply we are called as aluminium clad sheet. So this aluminium clad sheet is then this is this one. So this aluminum clad sheet mainly we are used in the aircraft industries. So this is the metal cladding diagram. One more diagram, let us see. So metal cladding. In the metal cladding, so this is the aluminum pure, that is 95.5%, and this is the aluminum and this is the duraluminum. So duraluminum is sandwiched between the aluminum and these are the rollers. When the duraluminum is sandwiched between the aluminum, now we are passing through the rollers and we are applying the temperature and pressure. We are applying the temperature and pressure. Here we are getting the aluminum clad sheets. Aluminum clad, this one is called as clad sheets. So this clad sheet is there now. This clad sheet mainly we are used in the aircraft industries. This duraluminum is sandwiched between the aluminum, pure aluminum. Then, so this one we are processed through the rollers, we are pressing takes place. At that time we are applying the temperature and pressure. Then we are getting the aluminum clad sheet. So this aluminum and clad sheet we are used in the aircraft industries. So in the making of wings we are used the metal cladding process. So in the metal cladding, a coating of a thin homogeneous layer of a coating metal on a base metal, a fused so that is strongly binds permanently either on one side or on the both sides, passed through rollers under the heat, that means temperature and pressure. All corrosion resistance metals like nickel, copper, silver, arum and platinum and alloys like steel nickel alloys can be used as cladding materials. Base metals on which cladding is done are mild steel, aluminium, copper, nickel and other alloys. Duraluminum is very light metal alloy used in aircraft industries. So metal cladding means the base metal is base metal is coated with dense, that is called as metal cladding. The base metal is sandwiched between the both metals, then passes through the rollers. When we are applying the temperature pressure, then we are getting the when we are getting the sheet, that sheet is called as metal cladding sheet. So these are mainly used in aircraft industries. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.